The use case for this pattern is when there's a language you can interpret and you can represent statements in the language as an abstract syntax tree. But that use case would apply to many types of languages, even though this pattern isn't necessarily a good fit for all of them. So keep in mind that this is a good fit when the grammar is simple. When it becomes complex, the class hierarchy of the grammar becomes large and unmanageable. Also, it's not the most efficient interpreter. The most efficient ones are usually implemented by translating parse trees to another form first. Regular expressions, for example, are often transformed into state machines first. Yet even then, the translator itself can be implemented by the interpreter pattern, so it is still applicable. Let's have a look at the consequences. The first consequence is an advantage. It's easy to change and extend the grammar. Grammar rules are represented by classes, and these can be extended via inheritance. Also, implementing the grammar is easy too, as all classes that implement the abstract expression have similar implementations. A disadvantage is that complex grammars are hard to maintain. There's at least one class for every rule in the grammar. So if you've got a large set of rules, you've got a large set of classes to manage and maintain. Let's have a look at the related patterns. The interpreter is related to two other patterns. The first one is the composite, as the abstract syntax tree is in fact an instance of the composite pattern. The second one is the iterator, because in regards to traversing the structure, an iterator could be used. And with that, it's time for the module summary. In this module, we covered the interpreter pattern. Not such a common one, but a cool one to end this course with nevertheless. Its intent is to, given a language, define a representation for its grammar along with an interpreter that uses the representation to interpret sentences in that language. Such a language can consist of terminal and non-terminal expressions. A symbol, which is the smallest meaningful part or unit of a language, is also called a terminal. Statements that are made up of terminals and are allowed by a language are called non-terminals. And that's it for this course. I hope you learned something, and I hope you'll be able to apply these patterns in your day-to-day development life, as they can really help improve your codebase. In case you have a question, don't hesitate to ask it on the discussions tab, or just send me a message on Twitter. Also, please consider rating the course. It gives us authors some feedback on whether we're doing this right or not. And with that, I have just one more thing to say before I go. You're ready to be awesome.